Everyone, I'm Ranjita. Today we are going to discuss about the applied physics. We're taking some topics that is a Messner effect and the high temperature TC. First, introduction to a Messner effect and high TC superconductor. A Messner effect is the complex exclusion of magnetic field from a superconductor when it transition into its superconducting state. High TC superconductors are materials that exhibit a superconductivity at high temperature, higher than the boiling point of liquid nitrogen. The high TC superconductors have the potential for practical application due to their relatively higher operating temperatures compared to the conventional superconductors. Next, we're going to discuss about the Messner effect. When was the Messner effect was discovered by who? The Messner effect was first discovered by Walter Messner and a robot in 1933. When a superconductor is cooled below its critical temperature, it expels all magnetic flux from its interior and creating a perfect diamagnetic state. This explosion of magnetic field occurs due to the formation of superconducting electron pairs known as copper pairs that carry a electric current without any resistance. Next, we are going to discuss about the superconductors. The superconductor is consisting of two types, that is type 1 and type 2. The type 1 that exhibit a complete Messner effect, expelling all magnetic field when they cool below the critical temperature. Then type 2, the superconductor exhibit both the Messner effect and mixed state at higher magnetic field. In the mixed state, the magnetic flux penetrates the superconductor in the form of the quantized vortex, allowing a limited amount of resistance free current flow. High TC superconductor. The high TC superconductor is also known as the cuprate superconductor or compressed of copper oxide layers and separated by other elements. Their critical temperature range from around a 30 K to above 135 K depending upon the specific composition and doping. The discover of high TC superconductor in 1986 by Bednorz and Muller, the field of superconductivity. Complex critical structure. What is mean by this complex critical temperature? High TC superconductor have a complex critical structure, often with layered arrangement of atoms. The complex structure give a rise to a unique electronic property such as a strong electron correlation and unconventional pairing mechanisms. Understanding and controlling their complex structures are a key challenges in the study and application of high TC superconductor. Next, mechanisms of the high TC superconductivity. The exact mechanism of ITC superconductor is still a subject of active research and debate. The proposed mechanism includes the BCS theory modified for unconventional pairing, spin, and the charge density wave functions. The complexity of these material makes it difficult to establish a single undefined theory for high TC superconductivity. Application of high TC superconductor. The high TC superconductor have the potential for numerous practical application, including power transmission, magnetic resource image, and particle accelerators. However, the challenges such as the metal fabrication cost and the brightness need to be overcome for the widespread adoption. Ongoing research the aims to improve the understanding of high TC superconductivity and develop new materials with higher critical temperature.